hydrogen, helium, lithium, beryllium, boron, carbon, carbon dioxide, water, sodium chloride, iron oxide. What are these things? Sit back, relax, and enjoy because today we will recognize that substances are classified into elements and compounds.
Nalibnos kinaindaklan nga aldaw kaadal adtoy ni Maestrong Eliocano amang iturong kada kayo ti pagsayaatan, pagbanagan ken pagdurasan ti siyensya. Come and join me as we explore the wonders of science.
Chemistry is a branch of science that deals with the study of matter, its composition, and the changes it undergoes. Matter is anything that occupies space and has mass. Earth is composed of different forms of matter. The air you breathe, the water you drink, and the food you eat are examples of matter. Based on its composition, matter can be classified as either a pure substance or a mixture. A pure substance is a matter that has distinct properties and composition that do not vary from sample to sample. It cannot be separated into two or more substances by physical or mechanical means. Distilled water is an example of a pure substance because it is free of any contaminants. Other examples of pure substances are table salt, the aluminum in soda cans, cooking oil, and diamond. A mixture, on the other hand, is the physical combination of two or more substances. The composition of a mixture varies for every sample. Changing the proportion of the substances making up the mixture varies the composition. Moreover, the substances that make up the mixture retain their chemical properties. Seawater is an example of a mixture because it is composed of salt dissolved in water. Sand and gravel, mud, jelly bean candies, and ice cream are examples of mixtures. A pure substance can be classified into elements and compounds. An element is a substance that cannot be broken down into simpler substances by any chemical processes. For example, distilled water is a pure substance. If you allow electric current to pass through it, water will be broken down into its compositions, hydrogen and oxygen. Hydrogen and oxygen, however, cannot be broken down into simpler substances. Thus, hydrogen and oxygen are elements, whereas water is not. Elements can be grouped into two major categories. An element can either be a metal or a non-metal. And, in a special case, it can be a metalloid. Generally, a metal can be distinguished from non-metal based on its physical properties. A metallic element is characterized by its luster or shiny appearance and its ability to conduct electricity. Metals such as aluminum, copper, iron, and silver are good conductors of electricity. Non-metallic elements such as sulfur, carbon, and chlorine are poor conductors of electricity. Here are some of the properties of metals and non-metals. All metals are shiny or lustrous. With the exemption of mercury, metals are generally solid at room temperature and pressure. Solid metals are malleable. This means that they can be drawn into thin plates or other shapes without breaking. Metals are ductile. They can be drawn into thin wires. Most metals have high melting and boiling points. Metals are good conductors of heat and electricity. On the other hand, non-metals are not lustrous in their solid form. Non-metals are either gases or volatile liquids at room temperature. Some non-metals can be solid at room temperature, but they have very low melting points, except for carbon in the form of a diamond. Nonmetals are brittle solids. They break easily. Most metals have low melting and boiling points. And lastly, most nonmetals are poor conductors of heat and electricity. The metalloids have the properties of metals and nonmetals. Some metals such as silicon and boron have properties of both metals and nonmetals. These elements are solid and shiny like metals but brittle like nonmetals. Silicon, boron, arsenic, and germanium are called semi-metals or metalloids. A semi-metal or metalloid is an element that shows physical properties of a metal but has the same chemical properties of non-metal. Various elements are used every day in different industries. As stated earlier, iron is perhaps the most important metal in the industry today. However, there are more metallic and non-metallic elements used in different industries for a variety of applications. One of these metals is mercury. It is the only metallic element that is liquid at room temperature. It is widely used in the production of caustic soda, paint, and various industrial and control instruments such as thermometers and thermostats. Carbon comes in many forms. Diamond and graphite are two of these forms. Industrial diamonds are those diamonds that are mostly used in drilling rocks and cutting small stones. Graphite is used as an additive to increase the hardness of steel and for the production of lead in pencils. The lead in your pencil is not really lead, the metal. It is a form of graphite. The metallic element copper is used in electric cables and wires. Moreover, it is also used as an integral electronic component. Most of your handheld devices contain copper in their circuits. Silicon is a metalloid used in manufacturing computer chips, glass, and ceramics. Laptops, desktop computers, and even smartphones have integrated chips containing silicon. Silicon is also used in cosmetics, pharmaceuticals, and in the production of insecticides. Other metallic elements such as aluminum and tin are used in manufacturing cans, containers, and various types of electrical equipment. Tungsten is used in steel production, metalwork, and light bulbs. Magnesium is used in the production of cement, rubber, and plant fertilizers. Lithium is used to make small but powerful batteries for smoke alarms, medical gadgets such as pacemakers, cell phones, and computers. Perhaps the most used non-metallic element in the industry is sulfur. It is used in manufacturing drugs and fertilizers. The most used end product of sulfur is the sulfuric acid. Sulfur is also used in oil refining and production of gunpowder. Nitrogen and phosphorus are both used in the production of fertilizers. Nitrogen is used in controlling pollution and is very effective in removing unstable organic compounds in liquids. Phosphorus is vital in the food production industry, especially in the areas of food preservation and manufacturing, the pharmaceutical industry, and the production of certain high-tech electronics. Elements are also known as the building blocks of matter. Though you cannot break them down into simpler substances, you can combine them to form more complex substances. Carbon, hydrogen, and oxygen are elements that, when combined at a specific ratio, can form sugar. Table salt is not an element because it is formed from two elements, sodium and chlorine. There are more than 100 elements known to people today, 83 of which can be found in natural substances. The rest of the elements are synthesized by scientists in the laboratory. The periodic table of elements show the arrangement of these elements based on their properties. Chemists use symbols to represent each element. These symbols are abbreviations of the element's longer name and are usually composed of 1 or 2 letters. The first letter is written in uppercase, whereas the second letter, if present, is in lowercase. The second letter is used to distinguish elements whose names start with the same letter. For example, carbon is C and calcium is Ca. Some elements have symbols based on their Latin or Greek names. The symbol for sodium is Na because its Latin name is natrium. Elements are made up of tiny particles called atoms. Different elements have different atoms. Atoms are the smallest particles or units of an element that can retain its chemical properties. A compound or a chemical compound is a pure substance composed of 2 or more elements that chemically combined in definite proportions. Pure water is composed of 2 parts of hydrogen and 1 part of oxygen. The characteristics of a compound differ from those of its component elements. Water, though formed from 2 gaseous elements, is a liquid. The common table salt is a compound formed from sodium and chlorine. However, the properties of sodium and of chlorine are very different from that of the compound salt. Just like elements, chemical compounds are represented through symbols. These symbols are called the chemical formula and are representations of the composition of the compound. A chemical formula is written using the symbols of the elements that make up the compound and subscript numbers showing the relative proportions of these elements. For example, water is 2 parts hydrogen and 1 part oxygen. Thus, the chemical formula for water is H2O. Likewise, table salt is 1 part sodium and 1 part chlorine. So, its symbol is NaCl. Compounds are made up of molecules. A molecule is a group of 2 or more atoms chemically combined. For example, a molecule of water is composed of 2 atoms of hydrogen and 1 atom of oxygen. Likewise, a molecule of carbon dioxide is formed from the chemical combination of 1 atom of carbon and 2 atoms of oxygen. To sum it up, a pure substance can be classified as either an element or a compound. Elements are the simplest forms of matter. Elements are either naturally occurring or man-made. Elements are made up of tiny particles called atoms. Compounds are formed when the atoms of different or identical elements chemically combine. The properties of a compound are different from the properties of the composing elements. Compounds are made up of 2 or more elements. There are various elements that are used by your body in the households and in different industries. That's it, mga ka-Ilyocano. Thank you for watching the video regarding the elements and compounds.